Yes, hello. Thank you very much for coming. So many of you. Okay, and now I have to. Yes. So as Christian said, I just recently, so 3 weeks ago, on January 2nd, I started at Get Your Guide. So who of you knows what Get Your Guide is? Yay. Okay, so it's a right. So before I was at Zalando selling shoes, and now so immediately in the onboarding, I realized there's something different about the brand, as you will see. So this is the normal template. I just took pictures, which they suggest you take for technical talks, and you will see it's quite funny sometimes. Okay, and today I want to talk about I've been a machine learning researcher for more than 10 years. Before I went to Zalando. And so the funny thing is, although I have that background, so the stuff that really interests me is sort of everything else you have to do after you know what machine learning is. And that's what I'm trying to talk about today. So Get Your Guide is essentially it's a website where you can book travel experiences around the world. It's really international. So we have call centers all across the globe. Our biggest markets are in Europe and Northern America, of course. And so we really want to have a really frictionless, great experience, like also in the app. So once you have the tour in the app, sort of you can do everything. It's and really great customer support and so on. And we call ourselves a marketplace, but you also book the activity with us. It's not like we just connect you to somebody else, right? So you can really once you have the account with us, you can forget about all the other complexities that might be there. So currently we have a number of other typical abstractions that we have is a HopOn, HopOff tours, right? So internally called HoHo. This is for when you book something on a bus and then you can hop off and look at activities and then get back. So we have extraction tickets, outdoor activities, walking tours, cooking classes, amusement park, and also transfers. So how to get from the airport to the hotel and so on. And of course, we're planning to expand all of that. All right. So the main question is, so how do you do now? So we have heard a lot about AI and the future of AI, but how do you actually do that in a company, in an e-commerce setting? Right, and the question is, so on the one hand, I mean, what people usually talk about are deep learning algorithms. We've already seen many examples of like very interesting and powerful things that can be done with machine learning algorithms nowadays. And then on the other hand, you have all these tools, right? So you have Spark, Hadoop, TensorFlow, Jupyter, like all the stuff. And the question is, so if you did these two things, and then, so who knows this, the AI hierarchy of need? Who has seen that blog post or that picture before? Okay, very good. So that's, I think it also comes back later in the talk. But essentially, there was a blog post by somebody who said, so if you want to do AI, one thing you have to take care is the data, right? So you have to, and it's like a long hierarchy. So you have to start collecting data, like very basic things before you can actually think about doing AI. So and still the question is, so if you have the algorithms, the tools, and the data, is that already AI or not? And I would say, so it's not that. There are still a few things missing. So what is there beyond algorithm tools? And this is, by the way, one of these great stock photos that we have. And I want to talk about I think further problems are also figuring out where to apply machine learning, right? So making the whole thing work with the product, person, and the customer. And then sort of technically, how do you architect machine learning applications? And then the last topic I want to talk about is teams and organizations. Okay. So the first topic, so business problems to machine learning problems, right? Because so very often when you read about machine learning, actually there has already been a lot of work has been done to take some real world problem and find a machine learning problem that you need to solve to do that, right? So if you, but very often if you're in a company, it's not really clear. So there are a few things where it's really clear, but actually often you have to figure out, okay, what are actually the problems and how do I reformulate a customer problem into a machine learning problem? And I want to talk a little bit about that. So Get Your Guide. So this is the one page overview. So in essence, at the top we have these activities you can book, right? And then there are suppliers who are actually providing these things, and from that we get the inventory that we can sell. And then you have a core part of that is of course the actual website or the app where you can browse, you can search, you can look at an activity, you can buy it, and then you get the ticket in the app. And then during the trip also, the app still continues to help you. Okay, and just from I think this is in some way a very typical e-commerce setup, right? So at Zalando it also was very, very similar. So you have some stuff in the top, and then you have people, like at Zalando, this were Adidas and other people who sort of provide that. And then you sort of become that point where you also have to curate what you sell and so on. And then essentially you have like an online process where you can browse and check out and so on. Okay. So where are typical, and of course there are like many typical places where you could apply machine learning here. So for example, on the beginning, right? So that you can do a lot of forecasting and analytics on the whole activity supplier inventory part, right? So what is the demand for certain activities, when, in which city, right? How are things working out for the customer? How are the reviews and all of that? And there, of course, the first thing is to get all the data and then do more classical like BI kind of stuff. But then you also maybe want to do forecasting, right? You want to figure out, so how will this be in a year from now, and then plan accordingly and do other things. And then on the website, of course, you have stuff like, so on the home screen, you want to have a lot of personalization, right? You want to take in like everything. You want to understand what the one customer is interested on, and then show something that's already very much personalized toward the customer. And then search, of course, is a very big topic, right? So you have to understand what the customer really wants just from what he puts in. On article pages or activity pages, right? Usually it has these recommendations, and then checkout and ticket and so on. There are like many opportunities for these. Okay. So this is like what everybody does. But like let's say if you start from scratch, so what is actually, and I think this is, how is actually this connection made between a business problem and a machine learning problem? And there are some details in there, I think, which people often overlook. Okay, so going back now to the very beginning. So we have the customer, very abstractly speaking, right? And the customer has a job that the customer wants to be done. So for example, figure out what fun thing to do while on a trip, right? And then what the company does is it offers a product that solves this job and provides value to the customer, and then the customer is willing to pay for that. So that's the idea. Right, and usually the product consists of several activities that have to be done by the company, sort of to build the product. And somewhere it can be that some of these activities actually that's the place where you have machine learning, right? So it's not very often that really machine learning is already the solution that the customer is looking for. But usually there's like one part of it where you really need it, or you can like make really great impact with that. Okay, and so probably you all know that, but just sort of my like one slide explanation. So what is machine learning? And in essence, it's a little bit like writing a program, but if you cannot really say exactly what it is that you want to compute. So usually if you have a programmer, right, you can say, I want something, like I want a database system, and if the customer books something, I want that everything goes into the database and the invoicing is done and so on. But for many machine learning problems, you don't actually know what that is, but you can provide a lot of examples. Okay. And then, of course, you want that works well on future data. So one classical example is recommendations, as I said. And sort of looking back at this sort of flow that I had, right? So the customer wants to book a great tour, and there are different jobs that the customer needs to do that. And one of them is to browse the selection, but maybe also compare prices, get information about the tour options, right? So what works for me and so on. And the product by which we deliver that is the website, and then different activities that the customer needs to be able to do on the website is, for example, retrieve and display the selection, filter results, show tour details, and so on. And one activity in there, right? And this is all stuff that doesn't really require machine learning, really. But one thing is to show similar articles or similar activities, okay? And that's a classical example which cannot be done well without machine learning. So this is how it looks like on the Get Your Guide website. So we have this, the ultimate Versailles skip the line guided tour. And then at the very bottom, you see like other stuff you could also be doing. Like taking a walk in the garden. What is the other stuff? Okay. So here already, there's in the recommendations, there's also another kind of Versailles guided skip the line tour, which is also maybe questionable. But anyway, so the problem is, right, it's very hard to write a program, like just by thinking about it, that gives good recommendation because it's very unclear what similar actually means. So you could typically, and I mean this has also been done, you could say like, let's stay in the same category or let's stay in the same city and so on. But usually the data isn't very like clear and so on, and it just doesn't work very well. But on the other hand, you have a lot of example data because people are on your website, they're browsing, right, and you can see like what are they looking at sort of in one session, what are they looking at together, what are they booking and so on. And then of course, so we are in this setting where we have a problem, we cannot really say how to compute it, but we have a lot of data, and then we can build that. Okay, but let's go a little bit further into sort of what like the problem is that you're actually going to solve. And this is sort of the slide I was working to in this section here, because there's like in the machine learning problem, you usually have a problem which is like similar to the business problem, but a little bit different. And actually, which also means that the machine learning problem is solving something different, and sort of having this distinction is something that people often mix up or they don't really remember. And then you have all these communication problems between like business people and machine learning people. And what I mean is the following. So from a business view, right, you want to show activities that are similar to a given one using all these examples. But when you translate that into machine learning, right, we still don't know what similar is. But what you can, for example, do is so one way to do recommendation is, so you show two activities, and then you want to know what the probability is that the customer will look at the other, given that the customer is right now on the first one, right? And this is something you could just sort of extrapolate from the data. You can just see this activity, you can make a table, how often are they clicked and so on, and then you won't be able to predict that well. And this also means that the metric, so from the business side, is something like customers find something they like, maybe measured in terms of conversion rate. On the other hand, in the machine learning view, you want to learn to predict something well on future examples, and then you're looking at something like, I don't know, prediction error or something like that. And very often, or I see, well, what happens often is there's sort of like the business metric and there's the machine learning metric, and it's not really clear to everybody that there's a difference between these two things. Okay, so this was my first. So this is like in a summary, right? I think we often think like in terms of algorithms, and machine learning, but usually there's like some work that needs to be done to get from the customer to the machine learning problem, and especially if you're working on something completely new, it's often really not clear, right? And then it can be a bit complicated. Okay, so the second part are sort of what do you need to do technically to bring machine learning into production. Okay, so what I sketched here is like a typical machine learning system where the model really provides some predictions live. So you have the customer on the very left who does something on the website that gets stored in databases and logs. And then there is some data extraction here that takes this data and prepares the data that is used for training. And then you have the machine learning problem, sort of the actual machine learning algorithm here that produces a model. Right, then this model is sort of somehow deployed in production, often in a scalable way, because you have to do it like many thousand times per second. And then that is what actually gets back to the customer. And then you need to have some monitoring on top of this here. So in this whole system that you have, machine learning is actually just a very small part, right? And often when you sort of as a data scientist focus on a problem, so you're doing all of this manually, data extraction, right? And then you focus on having a model that really performs well, but you don't really care about all of this. And then another thing that gets added in production is that you need to automate all of that, right? So I've had projects with data scientists where they worked on something for a month and then had a great model, and you said, okay, now let's put it into production. But so can we just automate? But you have to run the feature extraction every day, right? And suddenly they're like, what? I don't even remember what I did there, and that's of course a problem. Yes. So now looking at all these like different variants of like AI systems that have been built, I think you can sort of separate out different almost like design patterns in software engineering, right? So small solutions for part of the system that could be replicated. And then there are different areas like core machine learning. So this is, I think, what everybody is familiar with. Then the serving, so how to get the predictions in real time, data processing and feature processing, automation monitoring, and machine learning integration. So how the different ways in which the machine learning model can be integrated into an application. Let's talk a little bit. So I'm not going to cover all of these, but only 3 of them. So once you start, so let's start with the machine learning integration. So how is the machine learning model integrated into a bigger system? And I think there are at least 4 different ways. So the first is that the machine learning model actually just scores something, right? So for recommendation, for example, let's say you have built this model that is able to predict with high accuracy whether a customer will click on something, right? That is not a recommendation engine. That's just something that predicts a probability. But you could use that if, on the other hand, so every time you want to make a recommendation, you get a candidate set, which is hopefully not too large. Then you score all of these elements, and then you take the top 5. That now would be a recommendation system, right? Another way to use machine learning is just as some part pre-processing in a system that is otherwise sort of not built on machine learning. So for example, if you look at many of the autonomous driving systems we have nowadays, actually they're using a lot of machine learning in the object recognition part in the front, right? But the actual, sort of a lot of the actual planning is still classical control, more like that. There is another way, which is sort of similar to the scoring, is that you produce a model, but then you're actually using you're actually doing an optimization over something, and then this model that you have is just part of the system that you're trying to optimize. And then the last system is really where you have really end-to-end, right? And I think many people actually think when you have machine learning, you build more something like that, where the machine learning model does everything, but very often it's just a small part of your application. So now when it comes to sort of technically serving the patterns, right, I think many people also believe, you just take your model, put it behind the REST interface and you're done. But I think there are also at least 2 others. So this would be the 3rd column here, 3rd version. But there are at least 2 other ways, which I've often seen. And one is to actually have the model embedded in your service or whatever. So you don't actually call the system with another call or API call, because that would be too slow, but you really have the code for the system in your application, and then you load the model into the application. And another, I think, interesting version is where you just pre-compute everything and then put that in a database, right? So you don't have a machine learning model at all, but if the number of objects on which you do predictions is small enough, which could be, for example, I don't know, if you have 1 million customers, you could, in a batch system, once per day, predict everything for them, and then you put it in a database, right? And which is, from an operational point of view, very simple, because we know how to serve data from a database, right? So again, I think there are different. So people often believe okay, machine learning, and then you put it into a REST service and in a container and whatever, and you just start serving. But actually, also depending on the requirements that you have, could be simpler methods to do that. Okay, and then sort of maybe this is the most complicated from the 3. So I think also, one typical thing you have to do with machine learning is you have to pre-process the data first to construct the machine learning models that you have. And one problem often is that if you do that, then you also need to have access to these pre-computed features at prediction time. So for example, in recommendation, if you have a model that uses some statistics of the customer, like how often was the customer here last week or in the last month or so, or what brands does the customer like most, or which locations, then that's something that you can compute once, and then you train the model. But if you want to do the prediction, you also need to know how that feature vector looks like, right? And one way to do it is this is in the top here. So you pre-process the feature, and then you put them into some database, and then at serving time, so every time a customer comes by, you go to the database and you get the feature vector, and then you can actually do the prediction. And here the problem is, of course, that you compute this only once per day, and then for all the customers, like the new customers, you don't have any data for them. And there is a way where sort of if you can model the pre-processing step in a way that it can work on streaming data, you could use the same code up here, and then also in an online fashion, and sort of then also have in real time pre-process the data in the feature store, right? I think, and this is sort of like also a pattern I've seen quite a few times, but I think right now there are still no libraries that do that, because it's so every time you do that, your team will still start building this thing themselves. Okay, so that's like from the technical part, right? I think the main message is, so machine learning is like a very important part, but you have to build a lot of infrastructure around that. And I think there are some patterns, but not that many products already which you could just use for that. And then I think the last part is about how do you actually organize the work between data scientists and the team, and especially between data scientists and engineers. So this is again one of these stock photos. So this is how the like a flow chart how data scientists work, right? Which essentially goes a little bit like this. So you have a problem, and then you, as I said in the first part, you think about how you can formulate this as a machine learning problem. You get some data, and then you run some experiments. You have some idea what to try, and then if it works, right, and usually it does not work, then you have to figure out why not and make like one iteration. You have to try maybe different data, different methods, different problem formulation, and so on. And essentially you do that till you're done. And then if it works, right, then you can try on some more data and so on. And then if that really works, you go into this whole productionization step. But I think in essence, it's a very sort of scientific kind of work, right? So it's very hypothesis driven. You can't easily, like if you say, okay, we want to have done it in a month, you cannot really say like from day to day what you're going to do and what the steps are, because there's a lot of uncertainty. And now if you compare that with the way that developers work, right? So I made a scale here sort of from exploration, design, and coding. So the data scientist, I would say, works mostly or works more on the exploration side. So they know how to do that, how to work when there's a lot of uncertainty, how to reduce the uncertainty, and so on. But they're not that strong on the coding side, because very often a lot of the code they write is really just to figure something out, and then they don't need to do that. To maintain that. So the developer on the other side, right, so they really focus on the building. So they want to write code that is maintainable, that is robust, that scales well, and all of that. And it's very typical in a company that you build up, so you work on that same code base for years, right? That means you have to be really, really sort of almost strict about how you work. And the problem is, of course, that these are very, very different modes, right? And I think in all the So what I've often seen is that if there is no willingness to sort of understand the other side, then there will be a lot of fights, right? So developers will say, no, we need code reviews, and whenever you want to run an experiment, it has to be 4S principle, and so on. And on the other hand, I think also on the other hand is the developers often, I've seen, are not that good at dealing with uncertainty, right? So they really want to know, okay, this is the one thing I should build. Not that easy. And the question is, so how do you do that? And I think one is the more cultural part, right? So you want to have teams where each side is interested, right? You want to have data scientists who also want to do something in production and not just work on like interesting problems. And then developers who are also interested in learning more about that. But I think there's also like a technical side to that, where you ask, okay, how do we actually organize the work between the two? And there's one version which you could do is that you will make a really strict separation between everything on the data science side and the developers. So data scientists, they just work on the data on prototypes, and then they write a document that describes what it is that they found that worked. And then developers take that over and sort of write proper code and bring it into production and so on. Right, so you can do that, but the problem is that there's like a huge gap here. So it could be that the developers then they they try to fix things, or they misunderstood something, or it's not really specified, and then actually they will have something in production which is not what the data scientist worked on. And the other problem is, so once you have it in production, of course, you also want to iterate it, right? So you're doing what I had on the slide before, you're doing that thing, but now on a longer time scale, and then you have to go back and forth between what the data scientist has built and what the developer has built, which doesn't make a lot of sense. So what I've been working with past few years is a version where sort of you have the engineers build a system that is mostly like they want to build systems, but then there is a very clear interface where sort of the data science work can plug in, right? Which could again be really part of the same service or over some interfaces. And then you need data scientists which are willing to at least learn enough about engineering that they can maintain also this little part here, right? And that way, I think you have, like, this is one model which can work quite well, where you have good shared responsibility and interaction between the two. Okay. And then the question is, so once you have the teams organized, also, so how do you then do the organization on a larger scale in the company? And I think there are at least 3 different patterns also here. So one is where you have sort of like a center of excellence. You put all the data scientists in one team, and then they go around the company and work on different projects with other teams. You have the model which is a bit like with the document in the middle, which I call the throw over the fence model. You have the data scientists, and then you have software engineers and operations people, right? So you try to have every team work on what they are really good at. And then the last model sort of is you have fully cross-functional teams, so you have teams which are mixes of engineers, data scientists, and also product managers, right? And I think there isn't really no. So each of these models works well for some things and not so well for other things. So the center of excellence, I think that works really well when you're starting out. So the data scientists, they are really well connected. They have somebody to discuss stuff with. The problem here is that there is a huge gap between the data scientist and the production system, right? So we tried that actually at Zalando a few years back. And then the problem is you have these really great prototypes, but when you want to bring it to production, you really have to fight for that the teams find the time to implement it, and they don't know what it is and so on. So I think this model here, this works, seems to work quite well because so the data science, they can really just focus on their stuff. Software engineers really just focus on their stuff, and then very often also the operations people are separate, right? But on the other hand, with every switch, sort of, you have a big, there's a sort of a break in the process, and if you want to optimize all of it, can be quite long. But this could be good if you really want people to really just focus on what they're good at. And then finally, sort of in this cross-functional teams, I think this is the best in terms of everybody works towards optimizing the product and building the product. But of course, this is very demanding on so everybody has to be quite mature and willing to work with other people. And then you also have the problem that very often these roles feel quite isolated, right? So you need another thing like guilds or some tech exchange groups where data science can then talk to one another. Okay, and then finally, so here's it again, this AI hierarchy of needs, the whole data side part. So with e-commerce, I think it's also pretty more or less clear what you need. So you have most of the data comes from the website. I mean, and then all the supplier data and so on. And I think by now it's pretty standard that you try to collect everything in an event queue, which can then go into different outputs like the analytics, data lake, and so on, and then from there used for stuff. Okay, so I think this is from the organizational point of view, it's very clear. The problem in big companies is that these teams are then very, very far from one another, right? And often, so sometimes like the front end people, for example, they're not even aware how important their information is for machine learning, right? So for them, it's just like, okay, I have these events in here, and then if something breaks, they might not even know that somebody's using that data. So there's actually a paper by Google, which is called Machine Learning, the High Interest Credit Card of Technical Debt. Very interesting paper where they talk about that machine learning is very difficult for organizations because it just sort of naturally cross-cuts across everything, right? So machine learning usually integrates data and systems which have nothing to do from a business point of view. It's really like a different way to look at all of that, and that really creates a lot of friction. Okay. I think so one way to think about it actually is to say that actually the whole thing is a little bit like a physical experiment, right? So I worked with another data scientist who has been working on the CERN, on the big, what's it called? Accelerator. And there he said they had a really good culture about data. So they said there were so groups, I mean, as you know, right? So I don't know how many people work, there's thousands of people, and you do a whole PhD thesis about this one component which was in that sensor, or about that one sort of data preparation that you provided to everybody else. And he said they had a really great culture where there are sensors, and then there are people who take the raw data and turn them into these golden data sets, right? And then other people could use that, and I think sort of that kind of mindset is also required here, that everybody needs to know how important they are for machine learning. All right. So in summary, I think, it's not about the method and the tool. This is often like, I think what people talk about, because it's quite easy also to talk about it, because it's very isolated. But if you look at the bigger systems, it gets quite complicated. And I think the big questions are, so how do we identify where to use machine learning? Working with product people who are very good at knowing machine learning. So building AI machine learning systems, I think there are these patterns which are starting to emerge. So you don't have to redo everything from scratch, although we are still lacking a lot of the tools I think that are needed. And then, of course, the big question, so how do you set up teams and organizations for machine learning? All right, so thank you very much. If any questions, I think we still have a few minutes. And